All right, so we're going to continue. It says using decimals, explain what is the difference in the graph generated between the following. This is your time to reflect and make sure that you understand how to use decimals. All right, so we're going to work with these two first. And I went ahead and I typed them in. And let's see what we get. The other ones we can't see them because color. So let's say with the red one. So what we get are these vertical lines. And they're overlapping. This happens because it's got an equal sign. There's no f of x, there's no y. It's just the function equals something. And they happen to be the same because all they did was to subtract 6 on both sides, and that's how you get this one. So it gives you the zeros. This is how we solve. We know the answer. Then there's these two right here. So let me change from these two, this one and this one. So what we see here is the one that has equals 0, the red one, is still the vertical lines. It's just the previous one. But if we get rid of the equals 0, we get a parabola. Of course, they both have the same zeros because it's still the same function. Right. So let's say that we have the parabola. And what if we put an f of x in front of it? It doesn't matter. You still get the same thing. Okay. So x squared minus 3x minus 6. This just gives it a name. And even though it's got an equal sign because you have f of x, it doesn't solve it. So it just graphs the parabola. All right, the next two are this one and this one. And so let's say that I call f of x, like what we had before, you have the parabola. But what if I want to change the variable? So I'm going to call it h of t. And where x, I'm going to put a t. And it still graphs it because it's still the same function, same inputs and outputs. It's just different variables, but it's still the same thing. Now let's say that I have this one, right? H of t. What if I get rid of the h of t? Is it still going to graph it? No, it's not. Okay. In a case like this, Desmos really just wants to use x. Okay. I hope you find this useful for this question. Out of all 6 entries, which are the only ones that will generate a table for you? It's a good question. So let's find out. See, this one doesn't generate a table. No table, no table. This one does. This one, it's the same thing does. Let me see. Table, 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 table. Interesting. Okay. You are playing a game with points instead of cash. You start with 10 points, but as you play the game daily, the points you have go down. The table below illustrates this. Which of the following two expressions models how many points you have left as the days go by? So it's either this one or that one. See? And that's the table. 0 days, you had 10 points. After 1 day, you have 9 points. After 2 days, you have 6 points. After 3 days, you have 1 point. 4 days, you have negative 6 points. So the first thing you would do is graph the equation. I think I need to clear all this stuff. All right, so it'll be minus x squared plus 10. And the other one is going to be minus 2x squared plus 10. Okay, so the only difference is this number in front, okay? So if you think about transformations, it's going to move up 10 units. It's going to be reflected over the x-axis, and then this one's going to be vertically stretched. Okay, so now let's find the table. And so where are the parabolas? Oh, I got to put color on them. My bad. I'm so sorry. Okay, and how do we know which one is modeling this? So there's multiple ways of doing this. You can just type the points and see where they land, and you can also just make a table. All right, so we have 0, 1, 2, 3, 4, and the y values are 10. Ooh, wrong place. 10, 9, 6, 1, and -6. So as you can see, as I plotted the points, they actually land on the red one. So that's how we know that the red one, -x squared plus 10, is the one that models the table. I don't know why this is so zoomed in, but here we go. Let's take a time. All right, so the next question is find the rate of change. The rate of change, you have to be good at this, right? And they give us a table from where we're going to get the information. So they say when x equals 0 to x equals 2. So when x equals 0, the value of the function is 0, comma 3. And when x equals 2, the value of the function is 11. So then you do slope change, right? 0, 3 to 11. Just writing the slope formula right here. And you just look, 11 minus 3 over 2 minus 0. So is that 8 divided by 2 is 4. So the rate of change is 4 from those 2 points. All right, then 3 and 6.5. 3 is right here, so 3 comma 12. And 6.5, oh, right here, 0. 6.5 comma 0. So I write those 2 points down just so that they're nice and close, and I try not to make a mistake. And so I do 0 subtract 12, 6.5 subtract 3. I put it in the calculator and I get an answer. 1 and 5. When x equals 1, this is 8. And when x equals 5, oh, this is also 8. Well, I mean, it's a horizontal line, so it's going to be 0 slope. You can calculate it, 1 comma 8, 5, 8, and it's 8 minus 0, sorry, 8 minus 8 over 5 minus 1, which gives us 0, which makes sense. It's a flat line. All right, when the one with the slope of 4, if you draw a straight line from here to there, you can see that it's very inclined. That's a positive slope, a big slope. And then the other one should be negative, which is what causes this negative calculation. So what information do you get from standard form? Well, when you're in standard form, this right here is your initial value. Y-intercept. When you're in vertex form, you get the HK, which is the vertex. And remember, K is the maximum or the minimum. And when you're in factored form, the R and the S are the zeros, the solutions. Right? So each form gives you a specific type of information. All right, let's play a game. Which form do you need? When did the dolphin hit the water? We need a 0, so we need factored form. What was the highest height reached by the dolphin? So we need a max, so we need vertex form. What was the initial height of the fireworks launch? So we need the y-intercept, so we need standard form. When did the fireworks reach their maximum height? We need the vertex, and so we need vertex form. You flip the coin, when does it hit the ground? The ground, that means we need a 0, which means we need factored form. When do you reach the maximum profit? We need a maximum, which means we need vertex form. When do you break even in a business deal? Break even is when you cross the x-axis, so you need a 0, so we need factored form. And when does your profit equal to 0? Profit equal to 0 is when you break even, it's your x-intercepts. Your x-intercepts are your zeros, which means you need factored form.